Hello, and welcome to Math Matters. I'm Mrs. Halpin, and today we're going to learn about fractions, decimals, and percents by exploring a variety of models and real-world contexts. This content may be review for you, and that's okay. We are strengthening our understanding of rational numbers to prepare us for circle graphs in the near future. Here's our learning intention for today. I am learning to use a variety of models to represent fractions, decimals, and percents within real-world contexts. For this lesson, you will need paper and a pencil or something else to write with. We will pause while you take a moment to gather those materials. Now that you have those materials, let's get started. Which one doesn't belong? For this routine, select one fraction you feel doesn't belong. Why do you feel it doesn't belong? If you have more time, select another number and come up with a different reason it doesn't belong. Take a moment to jot down your ideas. You may be thinking 1/2 doesn't belong because it's the only fraction equal to 1/2, and it's the only unit fraction. A unit fraction is any fraction with 1 in the numerator. Or maybe you thought 2/10 doesn't belong because it's the only fraction that can be simplified to 1/5. You also may have been thinking that this fraction has the smallest value. Or maybe you noticed that this fraction is the only fraction that has a double-digit denominator. You might have thought 5/3 doesn't belong because it's a fraction greater than 1. If I know 3/3 is equal to 1, then 5/3 is 2/3 more than 1 whole. Lastly, if you chose 2/5 as the fraction that doesn't belong, you might have thought it's the only fraction that's close to 1/2. These are just some reasons that each of these numbers may not belong. You may have thought about different ideas or reasons, and that's okay. Your ideas can be different. There is no right answer here because there are so many ways you could think about this routine. 2/10 was one of the numbers in our sense-making routine. Now we are going to dive into understanding this number and the different ways it can be written. We can think about decimals as part of a whole, just like cents are part of a whole dollar. I can think about 2/10 as 2 dimes. There are 10 dimes in a dollar, so if I have 2 out of 10 dimes, I can say I have 2/10 of a dollar. I can also think about this as an area model. I have 2 spaces out of 10 shaded in. This may remind you of rods on a hundredths grid. 2 columns are completely shaded in, and we can call each of these columns 1/10. So 2 columns are 2/10. I can also name this number as a decimal with the 2 in the tenths place. I can think about 2/10 as a fraction is equivalent to 2/10 as a decimal. We can think about this amount as dimes. We can also think about it as pennies. There are 100 pennies in $1. If I have 20 pennies, I have 20 cents. I can write 20 cents as a decimal by writing 0.20 or 20 hundredths. When I read this number, I read it as 20 hundredths. 2/10 is equal to 20 hundredths. I can also look at this amount on a hundredths grid. One whole is split into 100 small squares. We call each of these small squares 1/100th because it takes 100 of them to make a whole. I have 20 out of 100 shaded in. I can write this as a fraction. All of these values are equivalent to 2/10. For example, 2/10 0.2 is equivalent to 20 hundredths, 0.20. We have named 2/10 as a fraction and a decimal. Now we're going to think about it as a percent. Percent means per 100 or how many out of 100. We use the percent symbol to represent a fraction with a denominator of 100. Let's revisit 2/10. If we think about percent as per 100, I can see that I have 20 shaded in out of 100 squares needed to make one whole. I can name this amount as 20 hundredths or as 20%. So 20% is the same as 20 over 100 is the same as 20 hundredths or 0.20. Let's think about some real life scenarios that we could describe using percentages. There are 100 fans at a soccer game and 65 of them are wearing red shirts. So 65 100ths or 65 out of 100 are wearing red shirts. We can also name this number as 65% of the fans are wearing red shirts. Something that I'm thinking to myself is that 50 out of 100 would mean 50% of the fans are wearing red shirts. So more than 1/2 of the fans are wearing red shirts. Have you ever felt excited because something you wanted was on sale? We can describe the sale or discount using percentages. If this dress costs $100 and it's 50% off, I would only pay half the cost or $50. Wow, that's a good deal. I love seeing discounts when I'm shopping. How could we estimate the percent of the glass that is filled with juice? I'll give you a little bit of time to think about that. We could think about the glass bottle as one whole or 100% when it is completely full. I can also think about where 1/2 or 50% of the bottle would be if it was half of the way filled. The juice is filled exactly halfway between 1/2 and a whole. It's a little bit more than halfway full, but it's not all the way full. I know that 3/4 is right in the middle, right between 1/2 and one whole. So if I know that the juice is 3/4 of the way full, how can I name this amount as a decimal and a percent? Well, let me go back to what I know about money. I know 3/4 can be written as 75 cents. So I know 3/4 is equivalent to 0.75 or 75 hundredths. Percent means per 100. So 75 per 100 can be written as 75%. So when we think about estimating what percent of the glass is filled with juice, it's about 75% of the way full. Another real-life example of percentages is what we see on our phones. Have you ever come across a message that says, low battery, 10%? I have, and that means I need to plug in my phone right away or it will turn off shortly. Let's dive into this idea of using percentages to describe cell phone battery life. Sometimes you might see an icon like this, the little battery, at the right-hand corner of a phone. If the battery icon is 100% filled in, then you have a full charge. This battery does not have a full charge. Take a moment and think about this. Estimate the percentage that the battery is charged. You might have noticed that the battery is a little bit more than 50% charged. A reasonable estimate might be 10% more than 50% of the way charged, so you could estimate that it is approximately 60% charged. What percent of this battery is charged? I'll give you a little bit of time to think about this. You might have thought about this battery as being split into 10 equal parts. Each part is 1/10 or 10% of the total battery life. So 4 parts or 4/10 of the battery could be named as 40%. I could also split this whole into 5 equal parts. Each part is 1/5 of the total battery life. I could also name each fifth as 20% of the total battery life. Since I have 2/5 of my total battery life shaded in, I could name this as 40 hundredths or 40%. I have named the battery life as 4/10, 40 hundredths, 40%, and 2/5. All of these values are equivalent to each other. They represent the same value or the same battery life remaining. What do you notice? You might be noticing that this battery is very low. It needs to be charged soon. You might be noticing that this battery is split into 10 equal parts. So each part represents 1/10 or 10% of the battery. You might be noticing that the line is between 1/10 and 2/10 or 10% and 20%. What might come directly in the middle of 10% and 20%? How could I name that value? 15% would be exactly between 10% and 20%. So you could say this phone is 15% charged. Jaylen went on a run. The water bottle marks where he took a sip of water. Lauren also went on a run. The water bottle marks where she took a sip of water. What is the same and what is different about these two images? Take a moment to jot down your thoughts. You might have noticed that both runs are represented on a number line. Number lines are helpful tools that can be used to represent distance. Sometimes we represent this distance with fractions and decimals labeled on the number line. Both Jaylen and Lauren began at 0. They both stopped for water after 3 spaces on the number line. Both of their runs are measured in miles. Let's talk about what's different. The value of each interval on their number line is different. Jaylen's number line is counting by tenths until he reaches 1 mile. Lauren's number line is counting by hundredths until she reaches 1/10 of a mile or 10/100ths of a mile. It looks like Jaylen's run might be a further distance than Lauren's run because 1 mile is greater than 1/10 of a mile. Now we are going to compare the point where both of them stop to take a sip of water. Let's take a look at Jaylen's run. The number line that Jaylen is running on is counting by tenths. So after 2/10, Jaylen would reach 3/10. This is when he took a sip of water. I can represent this distance or where he took a sip of water as a decimal, 3/10 or 0.3. I can also represent it as a fraction, 3/10. I could also say it's 30/100 or 30/100ths. And since I know percent is per 100, 30/100ths or 30/100 can be written as 30%. Now let's take a look at Lauren's run. This number line is counting by hundredths. So after 2/100ths, Lauren would reach 3/100ths. This is where she took a sip of water. I can represent the decimal 3/100ths, 0.03, as a fraction, 3/100, just like I can see in my hundredths grid. And since I know percent is per 100, 3/100 can be written as 3%. Decimals, fractions, and percentages appear all the time in our everyday lives. In today's episode of Math Matters, we connected decimals and fractions to what we know about money. We connected percentages to our cell phone battery life. Today we explored real-world contexts using a variety of models, including area models, a hundredths grid, and a number line. I'm Mrs. Halpin. I hope you have a great day and keep on counting.